Let's talk about series and parallel circuits. So first revision task, draw a circuit diagram for this arrangement. Okay, and here we go. So we've got our bulbs connected one after the other. This is called a series circuit. Okay, so we've got a circuit diagram for our left arrangement. Try and draw a circuit diagram for the right arrangement also. And we should have something that looks like this. So here are the two main types of circuits. So things can be connected in series, that's one after the other, or we could connect them across each other, and this is called parallel connection or a parallel circuit. So in order to understand parallel and series circuits, we're going to use bulbs with 100 ohm resistance, and we're going to use a battery of 12 volts. And the first thing we're going to do is just a bit of revision. So here's our circuit. We've got two bulbs, they've got 100 ohm resistance each. What is the voltage across each bulb? So pause, have a go, unpause when you are ready. Okay, so there's a couple of things going on here. So firstly, our bulbs have a total resistance of 200 ohms. If we divide the voltage by the resistance, that's the voltage being supplied to the circuit, we'd find that there's 0.06 amps running through that circuit. Because it's a series circuit, we'd have 0.06 amps everywhere. And that means, knowing that there's 0.06 amps and 100 ohms for one bulb, we know when we multiply those two, there's going to be 6 volts across each bulb. Now, the other way you could have thought about this is that the resistance is the same, so the voltage is going to split and be the same for each component, because they are the same resistance and they are in series. So, important fact here, so in parallel the potential difference or the voltage is the same across each bulb. What is the current going through each bulb? So pause, have a go, when you're ready, unpause. Okay, so we've got 12 volts across each bulb. They're both 100 ohms, so that's telling us that when we divide our voltage by our resistance, there's going to be 0.12 amps going through each bulb. What current is being drawn from the battery? There's 0.12 amps flowing through each bulb. However, what current is coming from the battery? So what you've got to remember is this: before the current splits, there will be 0.24 amps coming from the battery. So we've added the current going through each component, and it's 0.24 amps being drawn from our battery. What is the total resistance? So the voltage supplied to the circuit is 12 volts. So we're going to do 12 volts divided by the total current. So 12 divided by 0.24 is 50 ohms. Very interesting. So the total resistance is lower than each of these bulbs. And that's what happens when you connect components in parallel. The total resistance will be lower than the lowest resistance that you've got. So the last thing I want you to do is have a look at the two circuits where we've worked out the different values. So how are the parallel and series circuits different? So pause, make a note of the two diagrams, and just write down what's the same, what's different, what behaves differently.